Today's presentation is really focused around some of the, really I would say more basic, not necessarily in a basic standpoint, but the more commonly used features inside of SOLIDWORKS. We've really decided to focus a lot on some of the day-to-day things just to make sure everybody is squeezing every ounce of performance and capability out of the software that you have. And you've probably heard me say this a million times, but at DASI Solutions we really live by the mantra of you don't know what you don't know. So questions are really one of those things where questions are always legitimate if you just simply don't know what you're looking for. And a lot of times we find that people don't know some of the ins and outs about the more commonly used features. So you're really going to get a good feel for the depth of what the pattern features inside SOLIDWORKS can do for you today. So let's go ahead and start getting into the PowerPoint itself. There's a lot of different pattern features out there. Linear and circular are the type of features that you can pretty much expect any CAD tool out there to actually have. But when you get into a little bit more of the maturity of a tool, you start to get into some very complex types of patterns. Cosmetic I wouldn't necessarily call complex, but you'll see what that's about. But curve-driven patterns are definitely a complex feature. Feature-driven patterns at the bottom, you can really get a ton of performance with a minimal amount of input from a tool like that. So I hope you get a really good feel for exactly how each of those types of things functions. So before I move on to the next one, we're just going to launch one more poll here. And I really just want to get a feel for the audience for what types of things you guys do day to day. When you're talking patterns, it could be any one of the types of patterns, and really, multiple patterns can fit the type of bill. In other words, you can get 2 or 3 different types of patterns can get the same type of job done for you, just depending on what you're comfortable with. But basically what we want to do is just see a little bit about the percentage of what everybody does when it comes to patterns in their parts. Get one more vote in here, and I'll go ahead and share this with everybody. Basically, the way it shook down is you're really more on the low end, but if you're doing 25% of your parts have patterns in them, that's really a lot of things taking place in your system. And patterns are one of those things that, if used incorrectly, can definitely have some performance implications. So we want to make sure that you know the specifics that you can do to, again, squeeze every little detail that you can out of the tool like we have here. In this case, we're just going to go start with some of the basic features so you can get a real good feel for exactly how these things work. So we'll start off with some linear and circular patterns, and then I'm going to show you a nice little option here called geometry pattern. So let's just go ahead and jump right into those features. When we're talking a linear pattern, just from a definition standpoint, it's about as basic as it gets. I'm just going to go ahead and start out by sketching a very basic part. In this case, just a simple rectangle. Go ahead and extrude that just a touch. That's all we really need to do. Now on this part, I'm just going to go ahead and start another sketch. And it doesn't really matter what shape we use. And just to liven it up a little bit, I'll use an ellipse. And again, just a basic extrude. So the pattern features are all held under the same pull-down menu item up at the top. When you go ahead and hit the flyout menu on your linear pattern flyout tool, this is where you're going to see absolutely everything available with patterns. And we're not going to cover mirror today, but this is where that button is also housed. So we'll start off with a basic linear pattern. When you select the tool, as with other features inside of SOLIDWORKS, we're going to go ahead and take over the Command Manager location there for you. You can go ahead and do all the inputs over on the left-hand side in your property tree. So what we need to do is define a couple of things. Direction, if you're going to go second direction, there'll be a direction 2, and then some other little details there about what features or pieces are going to be patterned. So first of all, we define a direction. I'm going to use a linear edge of this part because it's convenient. It happens to be prismatic, but if you need a sketch entity in there, that'll work just as well. We want to go ahead and just make sure the direction is proper, because when I go ahead and select either features, faces, or bodies to pattern, it's going to go ahead and start my preview up. Now in this particular case, we're just going to go ahead and select that little extrude that we just did. Now for this one, I'm going to simply reverse the direction. It can also be done up here on the screen by hitting this arrow. We'll go ahead and change that spacing a little bit, maybe go to 25, and then we'll bump up the number of instances and drop that down a touch. So now I've got 5 instances in one direction. If we go ahead and use direction 2, I'm going to choose a different type of direction. And in this case, we go ahead and start bumping up the number of instances. You'll see the pattern begin immediately. At this particular point, if we go ahead and say OK to this, again, we have our basic linear pattern. Now with that, isn't always the result that you want is a complete grid system. So when I go back and edit this particular pattern, some of the nuances of all of these tools, regardless of the type of pattern that we're using, are little features like instances to skip. Now in this particular situation, by clicking open this window, we get these little magenta dots that show up on each instance preview. So if, for example, I wanted to eliminate these particular instances in the middle, we could go ahead and modify that just a little bit, make sure things look quite nice, and then we'll just simply say OK, and it gives us our pattern feature without those 3 instances in the middle. No extra features in the feature manager, no deleting or cutting or any other things after the fact to remove those types of details. Now, one of the other things that I want to point out here, and I hadn't planned on showing this, but it really just popped into my head, is something that I really see more common than I'd like to see when it comes to the way patterns actually get used. With this particular one, I'm going to change the way this looks just a little bit. I'm actually going to go ahead and simply bump it down to a single direction just for now. We're not going to use that second direction just yet. And I also want to make sure that just based on the location of this particular feature, that it's going to be a little bit more centered within the part. Oops, let's do that a little different way. How about that? Okay. This is something I actually see quite frequently. When we go ahead and take a look at this linear pattern, some people will put this particular instance of a feature directly in the center of a part. And while that may look like it's going to work properly for somebody, a typical misconception that somebody will do is they'll take direction 2 and actually use a similar edge. I'm just going to use the opposite side of the part, but an edge going in the opposite direction. And if I go ahead and actually pattern that out with the exact same spacing, we'll go ahead and bump that up. Let's go ahead and just make that 4 instances. Take a look at my preview on the screen. What it looks like is we have 3 instances going down in the bottom direction. That would be a total of 4, including the original. And then 5 instances going in the up direction. Again, 4 in the preview and 1 being the seed feature. The misconception here is that the result actually gives us, in this case, 9 instances. And that's actually not the case. The problem here is that when it patterns this, it's actually patterning the original pattern the opposite direction. In other words, what's taking place here is we're patterning all 5 of these 4 more times downward. And I can illustrate that a little bit by just changing the spacing a little bit. If you do that, you see a bunch of overlap that's starting to begin up on the top of this particular part. Furthermore, if I just simply go ahead and change that direction to something perpendicular to this, you'll see that we're taking the 5 instances in the seed and then we're patterning them to the right 4 individual times. And I'll go ahead and get rid of those instances to skip here briefly. So we want to avoid this type of thing, mainly based on a future feature I'm about to show you. But mainly what can happen with this is if we're using the opposite direction and we want to use a technique where you're actually going to go ahead and pattern it in this manner, there's a simple checkbox here called Pattern Seed Only. If we go ahead and select that, this will then truly be only 9 resulting instances. We'll just bump it up to 10 for a nice even number. To illustrate this, I'm going to go ahead and again switch that second direction perpendicular to the original. And in this case, you're going to see that it's only patterning the original seed feature vertically and horizontally. If we turn that off, the vertical pattern becomes the seed for direction 2. So that's a very specific thing that you need to know about the way patterns get generated, especially when it comes to the seed feature being involved. So with that, I'm going to switch over to a circular type of pattern. Let's just go ahead and grab that one. Now, a circular pattern is exactly the same types of inputs. What we want to do is just make sure we have the proper references. So under our pull down, we'll go ahead and select circular pattern. And in this case, we're going to be prompted for the features, faces again, or bodies to pattern. So if it was a multi-body part, you can grab individual bodies. With the features to pattern, I'm actually going to select these either graphically or through the flyout feature manager, whatever's more convenient. I can easily grab a boss, a cut, but I might be zoomed out a little bit too far to grab this whole. So, excuse me. We're going to hold on one moment here and wait for my audio to catch up. Okay. Just waiting for my audio to catch up with everybody out there. Okay, it looks like it's pretty good now. We can also select the features directly from the feature manager, which might be more convenient. In this case, we've got 2 extrudes and that shoulder bolt hole. From a parameter standpoint, what that's actually asking for is the center of rotation, the axis. Now that could be as simple as an axis going right down the middle. That could actually be a linear edge of the part. If I go ahead and actually select that linear edge, you can see that as the center of rotation. But in this particular case, I'm only going to pick a cylindrical face, which is then going to change that to being the center of the cylindrical axis. Using equal spacing, I can type in a total angle, and as I change the number of instances, it does the math for me, and my previews update nicely. So that way I don't have to worry about what my final spacings should be. It's just going to go ahead and do the math. Kind of a little lazy thing, but does the job. Now what we have is an original feature and then two resulting seed features. Now the nature of the beast on any pattern is, by design, if we go ahead and start changing the seed feature, go ahead and drag this dimension out, what you'll see is that the resulting features in the pattern are going to update right along with it. And again, that's design intent. That's something that I did want to do with this one. If we didn't, well, there's other ways that we can go ahead and individually edit the results of this particular seed feature. And the one I typically use is move face. I'll quickly do this because this is really data for a different webinar. But essentially, if I go ahead and grab a few faces of an instance of a result, I can actually go ahead and move those out completely independent of what the definition of this particular pattern feature happens to be. So there's a lot of different ways that we can go ahead and deal with editing individual instances of a pattern or the seed feature, frankly. But those are for another webinar. Just want you to keep an eye on exactly what's happening with each of those. A performance feature that really comes in handy with these is something called geometry pattern. And I want to illustrate that for you right now. I've taken this part, and I usually show this a little bit deeper into the example, but I wanted to show you guys a little bit of the setup so that you really get a feel for exactly what's happening right here. I've got an axis in the middle of my part, and to illustrate this, I'm actually going to take the axis in a plane, and I'm just going to make another plane. Now this plane, just based on definition, is going to be at an angle to that particular axis. So we'll go ahead and just call that 45 degrees just to be nice and clean. And maybe 30. 45 is a little tight. And then I'm going to take the resulting plane and simply control, pick, and drag just to offset that a little bit. So we're going to have a little plane sticking out in space here. Doesn't need to be too big. The reason I wanted to do this is because I'm going to take a little sketch that we have on this face, and I'm simply going to go ahead and extrude it. Patterns created from basic or blind end conditions are very straightforward. What happens is when you get into some of these more complex calculating type end conditions, like an up to surface or an offset from surface. If I actually say up to surface on this part right here, simply extrude that feature up to this plane, this is the wonderful result that we get, exactly what I expected to see. Where things start to change, however, is when you pattern these types of features. So let's get deeply into this. We're going to do another basic circular pattern. Now the feature of the pattern is simply going to be that extrusion and only that extrusion, and then the parameter is going to be the circular face of the outside of this part. What that'll do is instantly start to bring up my preview. Let's just go ahead and put 6 of these in. Now the preview itself looks exactly like the original feature, and in this particular case I want you to take the preview with a grain of salt, because here is what's actually happening. Let me go ahead and say OK to this. This is what you get. What happens on end conditions such as up to surface and offset from surface is that each individual instance of that pattern feature, each instance of this boss, as it gets patterned, calculates. Its end condition calculates, and in this case, I now have 6 performance hits as opposed to just 1 performance hit on the computer. But I show this to simply illustrate the fact that a lot of people will put a simple hole into a part, and they'll pattern it 50 times in one direction and 40 times in another, and you end up with several hundred holes, each of which is actually calculating. And that's why patterns really start to drain performance if you use them frequently. Now in a pattern, like a hole just going through a plate, we don't necessarily want them all to calculate. In this particular case, I illustrated it this way, but this is certainly not how I wanted this to calculate. So let me go back to my pattern feature. When you can, and this is something that I recommend you try every time you do a pattern, and if it fails, simply turn it off. We want to use an option called geometry pattern. By doing this, what it does is it ignores end conditions and patterns just the body itself, just the geometry. And in that case, the preview that we have is exactly what we get. So when you can, and this is going to be probably 90% of the time, turn on the geometry pattern check mark. What that will do is take care of that 50 by 40 hole pattern and make it as minimal on the computer as possible. It's going to be the least performance hit that you'll ever see. Now again, if you try to do that and it does give you a failure and says cannot create the condition with the geometry pattern, well, just simply turn it off. But trying it and using it is better than not trying it and not using it. And if you can't, you can't. But if you can, you're going to get a performance benefit out of that that's really going to help. Otherwise, as I said, with geometry pattern off, each instance and result of that pattern is actually calculating. So this one here is a pretty big deal. So that's a little bit about the basic linear and circular patterns, and then what the difference in geometry pattern is going to be. Basically, the hit here is that if it is calculating an end condition, well, in my case, geometry pattern worked on this one, but a lot of times that's going to be the line of delineation. But every basic pattern that you do, try to turn that on. It's going to make a huge difference. Now, patterns are also available in 2D basic sketches, and I typically don't recommend these because they don't have much downstream power, and frankly, up until SOLIDWORKS 2010, they really weren't terribly editable either. But I want to show these to you just so you get a good idea for what types of options there are out there. With this particular one, let me just go ahead and we'll use a little bit more complex part to illustrate this one. What we're going to do on this one is just go ahead and add a simple sketch. So over on the side of my part, what I want to do is just take care of inserting some geometry. To make this thing just a little bit more snazzy, I'm actually going to add a slot to this. So down here near the bottom, I'll just draw a simple line, and then we'll just go ahead and pull out our slot feature. Now the slot itself is obviously a pretty easy thing to do, pretty easy thing to modify. But at this point it is just sketch geometry. So with this, we actually have a linear sketch and a circular sketch pattern feature as well. And I really had no use for these up until recently again, but it's one of those things where it has its purpose, but I would avoid it if that purpose isn't going to fit. They're not as usable for downstream feature patterns, which I'll show you in just a little bit. But the inputs are the same. Linear sketch pattern, you can go x-axis and y-axis, and it will do that automatically if you want to. But mainly we want to go ahead and define the entities to pattern, which in this particular case is going to be the entire slot. Now for the x-axis, I'm just going to go ahead and bump up that spacing a little bit just so it makes sense for our display here. Just touch that over a little bit more. For our y direction, again, I can just go ahead and simply type in individual instances, and we can put in a spacing for each of those as well. That gives us a nice little preview for what we're going to get. There are some interesting little inputs that you can do with this, however. Right now you see we have a 90-degree angle and a 0-degree angle, and that's what's really defining the x and y axis. But on screen, there's some tiny arrows that actually show up. You can actually grab those arrows, you can change the angle, and therefore change the actual way the pattern looks. So if we add additional instances, you can obviously see that we've now changed spacings and angles all through this drag and drop. We're no longer just doing this at a common 40 millimeters. We've got a 40.67. And the angle obviously has changed a lot too. So we can go ahead and put that back to our original if we needed to. The key to this one, however, are these checkboxes. Add spacing dimension for both directions and display instance count. Now display instance count's been in the software for a little while. The add spacing dimension is actually brand new to SOLIDWORKS 2010. What this does is it gives us more of a real feature usability to it. In other words, I have dimensions like this instance number that I could use in configurations or design tables. The spacings themselves can be modified, which before a spacing dimension was ever added, these were kind of a creation time thing, and if you wanted to change it, you had to go ahead and delete and redo things. But this gives me a lot more flexibility than I had in the past. Now with a sketch like this, what I typically do is use it for a split line. On a part like this, I'm just going to go ahead and split the faces on this particular part. But what that'll do is give me some nice little volumetric tick marks on this particular bottle. The reason I wanted to do a split line is because as recent as SOLIDWORKS 2010, we've also enhanced the circular pattern to a point that it doesn't just support extrudes and cuts and basic things like that. What I can actually do is a circular pattern using a split line feature. So in this case, I actually have a sketch that I've used to split up these faces. There's no extrusion or cut to this. It's just a simple segmenting of these faces. Once we give this thing a central axis, then you'll see pretty quickly that we've now got a 5-instance preview. In this particular case, I just want 2 total. But what that will do is take this little logo that we've got, and it will simply go ahead and pattern it to the opposite side of the part. So from a seed feature standpoint, a lot less limitations than there used to be in the past. Okay, next thing we'll get into is some of the more complex patterns. Now when I say complex, I want to be very clear that this does not mean more difficult inputs. The complex patterns allows us to, much like a loft and a sweep, where it's a couple of sketches and maybe a couple of curves to create some really wild stuff. Sketch-driven patterns, it's just a simple series of points. Cosmetic patterns, well, you see that in a second. And then fill patterns really allows us to put the pattern in a more controlled environment. Now with sketch-driven, what I'm going to do is just show you this part here with just a bunch of points in space. Quantities and locations are driven by those points. With a table, now we're using XY information. So a little bit different, but a very similar output as a result of that. We'll go ahead and hit those, and then I want to show you what a cosmetic pattern is. I don't have a use for it myself, but it's something that I want to disclose just so in case you guys do have a use for it or a performance situation that may warrant it, you got to know it's there. And then fill patterns, which is actually quite a cool little pattern, really makes it easy to put patterns in place without having to delete a lot of extraneous things if the shape isn't just a simple square or round result. So let's go ahead and get into each of those. So all that said, I want to thank everybody very much for taking an hour out of their day to have some good interactive time with DASI Solutions. And on behalf of the rest of my staff, again, this is Darren Grosser here saying thank you very much, and let us know where else we can help you guys. So take care and enjoy the rest of your weekend.